Hello, this part of our lesson is on the group 1 metals in the periodic table and their properties. So as always, date, title, let me move those keywords up for you. Date, title and the do now task, which is to write down as many facts as you can remember about the particles that make up the atom. There we go, sorry about that. Okay, so title, group 1 properties. Your keywords there, soft, dull, effervescence, which means fizzing, and alkali, which is you've probably heard of acids. Alkalis are another group of chemicals. Write down as many facts as you can about the particles that make up the atom. Video can be paused now while you do that. Okay, I'm going to move us on to the answers for the do now task. There we go, sorry. So, protons, you might have said they have a positive charge, a mass of 1, and they're found inside the nucleus. Neutrons have no charge, a mass of 1, and they're also found inside the nucleus. Electrons are negatively charged. They've got a very small mass. You might have written 1 over 2,000 as being the mass of an electron. And they're found in the electron shells or energy levels orbiting the nucleus. And you might have remembered the 288 rule. The first electron shell can hold 2 electrons. Then the shells after that can hold 8. Okay, so these are the alkali metals. So they are known as the group 1 metals or the alkali metals. Okay, they're found in group 1 of the periodic table, obviously, which is that group on the far left. So you can see the 2 columns shaded yellow. That's group 1 on the far left. Group 2 is the yellow column to the right. So group 1 are lithium, sodium, potassium, rubidium, cesium and francium. So they're quite a special group of metals and we're going to be learning about why. So that's where we find them, the far left-hand side of the periodic table. This top square here represents hydrogen. Hydrogen is in group 1, technically, but it's not one of the alkali metals. Okay, so just be aware of that distinction. So why are they special? Well, they're very, very reactive, which means we hardly ever find the pure metal. We nearly always find these metals in the ground, but having reacted with something else. So, for example, we might find lithium as lithium oxide or sodium as sodium oxide, because they're so reactive that as soon as they are exposed to the air or to anything else, they form compounds. So they're so reactive that we have to actually store them in oil. So when we use lithium, sodium, potassium at school, we will always be storing the metals in little jars like that full of oil, which basically stops them from reacting with the air. What else is special about them? Well, they're really, really soft. You can actually cut them with a knife, and I hope to be able to show that to you at some point. And they're not as dense as most metals, so these metals actually float on water, whereas most metals will sink. And when they react with water, they form alkaline compounds. Now, we mentioned alkalis just now. You may not have heard of alkalis, but I'm sure you've heard of acids. Acids are a group of chemicals that react in a specific way. And alkalis are another group of chemicals that react in a specific way. So these metals, when they dissolve in water, they produce alkaline compounds. and that's why they're known as the alkali metals. So when you hear the term group 1 metals or alkali metals, we're talking about the same group of metals. So their characteristic properties then. This is what makes them special. We've already said they're very soft, and the softness increases as we go down the group. You might want to make notes as we go through, but I have got some summary notes for you to copy down in a minute, so don't be frantically scribbling. As I said before, they're less dense than most metals. They can float on water, or some of them can. Low melting and boiling points compared to other metals. Other properties they have are very similar to other metals. So as you would expect, they're good conductors of heat and electricity. They're shiny, but you only see that when you first cut them, because as they react so quickly that with the air, that as soon as you cut them, they will actually start to tarnish. They start to go dull as they form oxides. So this is a summary, so the video can be paused now while you get those written down. And moving on now. Some review questions for you to think about. Just check that you know the answers to these. You can jot them down or just look back at your notes and think them through. Maybe talk to the person next to you. Where are the alkali metals found on the periodic table? How are they stored and why? And what are their properties? So again, the video can be paused here. And the answers then, they are found in group 1 on the left-hand side of the periodic table. They're stored in oil to prevent them from reacting with the air. And they've got lots of properties similar to other metals, but their unique properties are that they're very, very soft and they're very, very reactive. They're also less dense than most other metals. Okay, so what exactly do we mean by density? We talk about this a lot in science, and I want to make sure you understand what we mean. So if a material or a substance is very dense, this means it's heavy for its size. So I want you to think about an example. If you were to hold a metal ball in one hand and a wooden ball in the other, and they were exactly the same size, which one would you expect to be heavier? Well, you'd expect the metal ball to be heavier. And that's because metal is heavier for its size than non-metals. And why is that? Why are some materials more dense? Well, if the particles in the material are heavier than particles in another material, or if the particles in one material are more tightly packed than the particles in another material, then that material is going to be more dense. So density is to do with either the mass of the particles inside a material or how tightly packed those particles are. I've talked through that, so I'm going to scroll through. Okay, so how do we find out the density of an object? Well, density can be calculated if we know the mass of an object, which we find by sticking it on some scales, and the volume of an object, so how much space it takes up. I'm not going to go into how we measure volume today, but we'll do that at another time. But if we know the mass and the volume, and we do mass divided by volume, that tells us the density of an object. So for example, if substance A has a mass of 3 grams and a volume of 10 centimetres cubed, what would its density be? Well, we know that its mass is 3. We know that its volume is 10. So to find its density, we simply do 3 divided by 10, and that tells us that our density is 0.3 grams per centimetre cubed. In other words, if I had 1 centimetre cubed of substance A, its mass would be 0.3 grams per centimetres cube. So it's quite simple. If we know the mass and the volume of an object, we simply do mass divided by volume. So have a go at these density calculations. There's some questions here for you to have a go at. The video can be paused while you do these. If you need to use a calculator, you can. Perhaps your teacher will let you just get your phone out of your pocket to use the calculator on your phone, or there are, if you're in school, there are calculators in the classroom. So the video can be paused while you do these. And I'm now going to show the answers. So for number 1, we should have done a mass of 20 divided by a volume of 10, giving us an answer of, that's wrong, 2. Grams per centimetre cubed. For number 2, an object with a mass of 15, volume of 3, 15 divided by 3 is 5 grams per centimetres cubed. And lastly, 70 divided by 5, 14 grams per centimetres cubed. So for some of you, those calculations might have been quite straightforward, but the more we do these things, the better we remember, and we do need to remember how to calculate density. So back to our alkali metals. Here we have the density of the alkali metals as you move down the periodic the group 1 of the periodic table. So lithium is at the top, cesium is at the bottom. So have a look at those numbers and what you notice about density. Well, the general trend, in other words, the pattern, is that as you move down the periodic table, the density increases. That's not a perfect pattern because, as you can see here, density of potassium is actually slightly higher than the density of, density of sodium is slightly higher than the density of potassium. But generally speaking, the trend is that the alkali metals get more dense as we go down the periodic table, okay? So comparing those to water, water has a density of 1 gram per decimetre cubed. So which ones of those are going to float on water? Well, the answer is lithium, sodium or potassium, because they have a density less than water. Objects with a density greater than 1, which is the density of water, are going to sink, and these 3, which have a density of less than 1, will actually float on water. Okay, so remember, trend means the pattern. So have a look at this table. What is the trend in melting and boiling points as we go down the periodic table, down group 1? What do you notice about the melting and boiling points? Well, you should have noticed that as we move down at group 1, the melting point is getting less or decreasing. And the same with the boiling point. As we move down group 1, the boiling point is decreasing. And you might also have noticed that at the top of group 1, there's quite a big difference between the melting and boiling points. The melting and boiling points have almost doubled, or rather almost halved, as you move down group 1 between lithium and sodium. But once you get towards the bottom of group 1, the melting and boiling points are much closer together. So why is that then? Why is it that the melting and boiling points decrease? Well, it's because as you go down group 1, the atoms of the metals get larger. So in metals, larger atoms are less strongly attracted to each other than smaller ones. And that means that when we heat the metals up, remember let's say we're heating a metal and trying to melt it, what we're doing is giving the particles more energy, the atoms more energy, and the atoms start to move more, and gradually the bonds between the atoms weaken, and the atoms are able to move around each other. Well, in large atoms, the bonds or forces of attraction between the particles, or atoms, are actually less strong. So it's easier to melt or boil metals with larger atoms. We don't need as much energy, and therefore the melting points and boiling points are actually lower. Okay, so have a go at copying and completing this now using the keywords in the boxes. So pause the video. So I'm going to show the answers now. So going down group 1, the density increases and the melting and boiling points decrease because the atoms get larger. And the challenge question was, what makes alkali metals quite reactive? I'm not expecting you to know this, but any bright sparks who already know something about the alkali metals might know that it's the outer electron on a group 1 metal that is involved in the reactivity. And the further away the outer electron is from the nucleus, the more reactive they are. We will cover that in more detail another time. I'm not going to go into that now. Okay, this is the last thing you're going to do today, or last task I'm going to give you on the video. I want you to have a look at these graphs and see if you can describe what you can see. So let's have a look at the graphs first of all. We've got a graph showing temperature. Temperature is going up our y-axis. So highest up here, 2000. Then we've got our group 1 elements going in order as we see them on the periodic table: lithium, sodium, potassium, rubidium, and cesium. There's one missing, francium. And our second graph is showing density. So density on our y-axis, so 0, 1, 2 grams per centimetres cubed for density. And again, our group 1 elements shown on the bar chart here. And question A, describe the trends in the melting points and densities of the elements going down the group. So can you describe for me, please, the pattern that you're seeing in melting and boiling point and density on the graph? And then question B, give the name of the element which has a property which does not fit a trend. So there's one element that has a property that doesn't quite fit the overall pattern. Which element is that? So the video can be paused now while you write those down, and I'll go through the answers. Okay, so the trends, you should have said that melting point, which is these grey blocks here, melting point decreases as we go down the periodic table. Boiling point decreases as we go down the periodic table. You may have said that it decreases very quickly at the top and then slows down. And then overall, the trend in density is that there is an increase in density as we move down the periodic table. But the one element that doesn't quite fit that trend is this one here. This one doesn't quite fit this increasing pattern, and that is potassium. So well done if you got those right, and hopefully if you didn't, you now understand what the answer should have been. That's the last task you're going to see on this video. If it's not yet the end of your learning time, then please go back over the notes you've made today. Try and learn and remember the information that you've been taught today. And if you still have some time left, then I would suggest that you go back over the notes that you've made over the last 2 or 3 lessons, or the notes that are in your books, and see what you can remember. Maybe highlight some key points that you struggle to remember so that you can keep going back to those and learning them. Okay, hope to see you soon.